Hi guys, just as I promised that I'm going to send you the video on trigonometry 2. Here we are. Boom. Application of trigonometric ratios. So in this particular lesson, we are going to look at how we can apply the T-ratio we learned in the previous lesson, especially the T-ratio with respect to right angle triangle. Remember, in the previous lesson, we also look at T-ratio of special angles. What I mean by T-ratio is trigonometric ratios. So in this lesson, we want to see how we can apply them in solving angles of elevation and depression problems, as well as problems involving bearing and distances. Remember to stay put with your calculators and coffee or table because we're going to do a whole lot of calculation in this lesson. Let's begin without much ado. Angle of elevation and depression. Before we talk about looking at this, where we see that elevation simply means looking up and depression simply means looking down, we are going to watch a very brief video that explains what elevation is all about and what depression is all about before we proceed. All right, let the video now appear.
Introduction to angles of elevation and depression. Every day, we look at different things around us. We look up to see things above us. We look down to see things below us. Angles are formed when we look up or down, and these angles are called angle of elevation and angle of depression. First, let's follow Dylan around the park to see the different angles of elevation and depression. Dylan looks up at the bird on the tree. When he looks up, there is an angle formed. Let's find out where this angle is. Remember, Dylan was looking straight like this just now. Then he looked up at the bird. There is an angle here. We say this is the angle of elevation. Elevate means to lift up. With this angle of elevation of the bird from Dylan, he takes a close shot of the bird. Next, Dylan now needs to locate the crocodile farm. He sees a signboard and he tilts his head. Again, there is an angle of elevation of the signboard from Dylan's eyes. Remember, Dylan was looking straight like this just now. Then he looked up at the signboard. There is an angle here. This is the angle of elevation. Dylan cannot see the words clearly. He walks nearer to the signboard. The angle of elevation of the signboard from Dylan increases as he walks nearer to the signboard. There it is. The crocodile farm is over there. He walks to the crocodile farm. At the farm, he sees the crocodile and he looks down at it. When he looks down, there is an angle formed. Let's find out where this angle is. Remember, Dylan was looking straight like this just now. Then he looked down at the crocodile. There is an angle here. This is the angle of depression. Depress means downwards. With this angle of depression of the crocodile from Dylan, he takes a picture of it. He walks a few steps on the platform and sees a mud skipper opening its mouth. That is a rare sight. He tilts his head down to capture the picture. Again, there is an angle of depression of the mud skipper from him. This angle is larger than the angle of depression of the crocodile from Dylan because the mud skipper is nearer to Dylan. He took a picture of it. Now that we have seen angles of elevation and depression like these, do you notice any similarities in them? Notice that both angles of elevation and depression have a horizontal line. Notice there is also a line touching the horizontal. It is this line that connects the object from the observer's eye. It's called the line of sight. Thus, an angle of elevation or an angle of depression is between a horizontal and the line of sight. The angles are also at the reference point, and the word from is important to determine the reference point. Adding on, is there any relationship between these two angles? Let's continue following Dylan to find out. Dylan sees a squirrel on the tree. There is an angle of elevation of the squirrel from him here. Let's draw the horizontal and line of sight. Can you identify it? It is here. Interestingly, the squirrel looks back at Dylan. There is an angle of depression of Dylan from the squirrel. Let's draw the horizontal and line of sight. Can you see it? It is here. Since both horizontals are parallel and are cut by the same line, these two angles are equal.
So I want you to pay attention to this now. Look at the structure and how you can draw angle of elevation and depression for them to be equal. Remember, if you draw them like this, they are alternate angles. So elevation and depression in this case that you can see on the screen are equal. Take note of this. This is one of the key things that you need to understand about angle of elevation and depression. So that if you are given the angle of depression, you can actually form the equal side of a right angle triangle. Then you can calculate. Take note of this structure. You can see here that the angle of elevation and depression in this format, when you draw them in between the two parallel lines, just like they act as a transversal. Where remember we look at this the alternate angle. So in this case, we apply the alternate angle principle to show you that the angle of elevation and depression in this case are equal. So this video has enabled you to see the difference between angle of elevation and depression, their similarity and their equanimity, that is their equality. So,
Dylan takes a picture of the squirrel and walks on. All in all, when we look up, an angle of elevation of the object from us is formed. Specifically, angle of elevation is the angle between the horizontal and line of sight. When we look down, an angle of depression of the object from us is formed. And an angle of depression is the angle between the horizontal and the line of sight too.
Okay, so that is just to it. Let's return to our slide now. Okay, so here we are. Now that we've known the difference between angle of elevation and depression, we will now see how we can solve problem involving elevation and depression. So you can always pause this video, or you can replay it over and over again to make sure you grab the whole thing. Okay, so just trying to flip through for you to see once again elevation and depression, the eye level as well. Okay, you look at this, it has great application also in basketball. When you want to throw your basketball, you should be able to know the feet, the height of the one that is about to shoot, the distance between him and what the basketball, and then you look at this structure, you can calculate the value of theta here, which is actually equal to this alpha. So this is the angle with which you can shoot this ball and you will get the net exactly. This is one application of what? Angle of elevation and depression. Okay, so problem one. At a point 25 meters away from the base of a water tank, the angle of elevation of the top of the tank is 45 degrees. What is the height of it? Anytime you see 45 degrees, just know that the answer is equal. So I'm going to show you what you need to do here, and then you solve this problem very quickly. And then you need to draw a simple at a point away from the base of the water tank. This state for the water tank, and then you need to draw another point away from the water tank, and the point is 25. The point is 25 meters, and there's an angle of elevation of at the top like this. So the angle of elevation like this, according to this, is when this is right angle, is 45 degrees. This is 45 degrees. Permit me to write it. 45. This is 45. And now there is a distance. There's a distance of the points away from the foot of the water tank, and the distance is 25 meters. 25 meter. And then what we are asked to find is actually the height of the water tank, which you can label as H. You see here, what you need to use is opposite over what? Adjacent. Opposite over adjacent, which is tan 45. Here, tan 45 is 1, so the height is simply 25 meters as well. So it's very simple. When we play this video, you can grab the whole thing here. Okay, so let's move on to a more complex problem now. So let's look at problem 2. If the shadow of a building increases by 10 meters when the angle of elevation of the sun rays decreases from 70 degrees to 60 degrees, what is the height of the building? If the angle of a building increases by 10 meters when the angle of the elevation of the sun rays decreases from 70 to 60 degrees, what is the height of the building? So we are going to draw this in our next to see how we solve this simple problem. Here is the diagram. Now, let the building be AB and the height of the building be H. As you can see, the building is AB. The angle of elevation of the sun increases from 70 to 60. Look at it. Sorry, it decreases from 70. It decreases from 70. Now, look at this. The first, it is 70. This is elevation. Then it decreases. As it decreases, another distance. It decreases 10 meters away. Remember, again, 10 meters. Building increases by 10 meters when the angle increases. So the shadow increases by 10 meters. Here it is. Look at the structure to point from point 1 to point 2. And then we have this. You can see clearly the depression and what that decreases from 70 to 60. See the structure opposite, like we said, opposite side and alternative angles are equal. So what we need to do now is to calculate H. So that means we are going to form an equation for H, with which we need to equate to get the value of X. And after which we can use triangle ABP2 to calculate H. Or we can use triangle ABP1 to calculate H. But once we form the equation for H in terms of X, when we get X, we can come and substitute the value of X and calculate H. Follow me to the next slide and see how we solve this problem. Okay, here you can see the step-by-step problem, but I need to go to where I will show you the diagram as we do it step by step. Here is the diagram. So the first thing that we need to do here from the diagram, in triangle ABP1, look at the diagram here, ABP1. Opposite over adjacent is what? Tan 70, which is H over X. Cross multiply, you will have H equal to X times tan 70. You have equation 1 as we formed. Let us consider triangle ABP2. In triangle ABP2, we are still going to look at opposite over adjacent. That is AB over BP2. Here it is. AB over what? Tan 60 degrees equal to AB over what? BP2. BP2 is X plus 10. Side BP2 is X plus 10. So cross multiply again, we have our H equal to X plus 10 times 60 degree, equation 2. So if H is equal to X times 70 degree in equation 1, and H is equal to X plus 10 times 60 degree in equation 2, we will now equate equation 1 and 2 to solve for X in this order. Open the bracket in the right hand side, you have what? And 60 is actually 1.7, and times 70 is 2.7x equals to X plus 10 times 1.7. Open the bracket in the left hand side and you will have this. Collect right hand to solve for X, which you will have your X to be 17. Now, go to equation 1 or use any of the equations. Substitute x equals to 17. H is equals to 17 times 70. Here is it, which is times 7 is already 2.7. So H is equal to 17 times 2.7. Therefore, the height is 45.9 meters. The height of the building is 45.9 meters. Replay this and pause to grab the whole gist in this solution. Now we look at problem 3. Problem 3 is a little bit complex but very simple to solve. From the top of a building, of a 200 meter high building, the angle of depression to the bottom of a second building is 20 degrees. From the same point, the angle of elevation to the top of the second building is 10 degrees. Calculate the height of the second building. Think about this problem as I take you to the next slide and show you how to solve it. Remember to play this video over and over again. Pause to grab the whole gist in this lesson. So let's look at the diagram. The diagram below shows the two buildings and the angle of depression and elevation respectively. So from the first building, which is 200 meter high, the angle of depression to the second building, we say is what? 20 degrees. And from the same point, the angle of elevation to the top of the second building is 10 degrees, as you can see the structure. So you can look at this structure, 20 meters here, to this point is 20 meters. So for us to find the height of the second building, we need to find the height above here, which is H2. We need to find the height above here, which is what? H2. For us to find H2, we need to find the distance between the first building and the second building, which is L. So we are going to use this system. Let me show you this. We are going to use alternate angle. Here is also what? 20 degrees. Look at what I'm doing. 20 degrees. Here is 20 degrees. Angle of elevation equal to depression. So we are going to say opposite over adjacent. Opposite over adjacent to get L. Opposite over adjacent. Opposite over adjacent, which is tan 20 is equals to 200 over L. So just cross multiply and get your L. When you do that, your L will be equal to 200 divided by tan 20. And this L here, this distance here is the same at what? At this distance. So we can now use whatever you have for L. Here it's also L, you know, or opposite side of rectangle. Here is also L. So we can now use this angle theta to get opposite over adjacent to calculate our H2, then add it to 200 meters. That is the height of the second building. So let's go to the next slide where we see the detailed solution to this problem. So once again, here is the diagram. So let's start. Like I said, tan 20 is equals to 20 over L. And here you get your L to be 20 divided by tan 20. And if you do that, you can also drop the answer. Remember, I said that L is also the same thing with the second diagram. So tan 10 is equals to H2 over L. And then you will have your cross multiply, you have your H2 is equal to L times tan 10 degrees. This is another short method of doing that. So if what you're going to do here now is to equate your L and to solve for what? Tan 20, to solve for H. So here, when you equate both sides, you are going to have height of the second building to be 200 plus 200 times 10 over tan 20. What I'm trying to do here is to show you that there's actually a shortcut that you can follow at the same time and arrive at this solution. Or you can get, first of all, the value of N and then go and get the value of H and add it to 200 meters, which is what you see as the height of the second building from this complete solution, which is 296.89 meter. So the value of H2 that you will calculate, once you do that, it is 96.89 meter. So add it to 200, you get the height of the building to be 296.89 meter. So that is how you calculate the height. There are different ways to do that. You can follow this, or you can follow the other method. So bearing and distances, let's look at this problem. The man set out to travel from A to C via B. The man set out to travel from A to C through B. That's another word to use for via. From A, he traveled a distance of 8 kilometers on a bearing of 30 degrees east of north, or you can call it 30 degrees east to B. From B, he travels a further 6 kilometers due east. Calculate how far C is north of A, east of A. And calculate the distance AC correct to one decimal place for a question. A man set out to travel from A to C via B. From A, he traveled a distance of 8 kilometers on a bearing of north 30 degrees east to B. So let's get a diagram for that. Here is the diagram. From A, he traveled, I want to show you the diagram I've been drawn already, but permit me to show you this in detail. From A, he traveled 30 degrees. Look at it, 30 degrees to point B here, 8 kilometers. You can see the 8 kilometers there. And from B, he now traveled 6 kilometers to C. 6 kilometers to C. So you will need to join AC, which is what this diagram you can see, AC. They say how far north of A? How far north of A? So you complete this here. This is the north of A. And then this diagram like this. So you are going to know the distance from C. The distance from C, from A to C, which is AC. And then you are going to know his distance north of A, that is NC, 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 and then AN. That is what we are going to calculate